If you had to name one tech trend that's undeniably the hottest right now, it would be AI. These days, what AI can create has become so refined that it's genuinely hard to tell it apart from the real thing. And when you talk to conversational AIs like ChatGPT or Gemini, it can feel surprisingly similar to talking to an actual person. So here is the real question. Do these chatbots actually think logically? The answer, right up front, is no. AI doesn't think. And yet, it often feels like it does. So why is that? Why do we experience it as if there is real reasoning happening behind the words? In this episode of Dr. SciVera Studio, I'll break down how conversational AI works and the core idea that makes human-like conversation possible step by step. And before we begin, please hit the subscribe button in the bottom right. Alright, let's get started. Before we dive in, let's take a brief look at the history of conversational AI. Its origins trace back to the 1950s. At that time, Alan Turing posed a foundational question. If a machine can hold a conversation that's indistinguishable from that of a human, can it be considered intelligent? A few years later, in 1956, the Dartmouth Conference marked a turning point. It was there that artificial intelligence began to take shape as a formal academic field. By the 1960s, early conversation programs such as ELIZA had begun to appear. However, these systems were limited to mimicking sentences based on pre-written rules. They struggled to maintain context and were unable to follow a conversation in any meaningful way. After that, research into conversational AI continued, but for a long time there were no major breakthroughs. Then, in the 2010s, several key technical factors finally came together. As a result, conversational AI systems began to carry on conversations while preserving at least some sense of context from earlier parts of the dialogue. As these advances accumulated over time, they eventually led to the conversational AI tools we use today. So the question becomes this: how can modern conversational AI, which can sometimes appear so human, produce behavior that feels human-like in the first place? Human thinking is a process that begins with understanding and interpreting information and then moves on to making judgments based on that understanding. For example, when we read the sentence "apple is a fruit," we naturally imagine what apples look like, their color, their taste, and other familiar traits. Through this mental imagery and background knowledge, we grasp the meaning of the sentence. That understanding then flows directly into our next judgment or action. This is how human thinking works. AI, however, does not go through this kind of understanding process. Instead, drawing on patterns learned from massive amounts of data, AI calculates which word is most likely to come next, purely based on probability. Put more simply, a conversational AI is a system that generates language by stringing together the most statistically plausible words, one after another. This is the core principle behind conversational AI. And to carry out these probability calculations, AI processes information in a way that's fundamentally different from how humans think. When AI processes a sentence, the very first thing it does is break that sentence down into extremely small units. Take the sentence "apple is a fruit" as an example. When this sentence is given to an AI system, it is split into pieces such as apple, is, a, fruit, and even the period. There is a clear reason for this. AI cannot intuitively understand the meaning or purpose of words. Humans can grasp the meaning of an entire sentence at once through thinking, but AI cannot. Because of that, it must first break a sentence down into small units that can be handled mathematically. These units are called tokens, and the process of breaking a sentence into them is known as tokenization. Once tokenization is complete, the AI moves on to the next step. Each token is converted into a mathematical representation, allowing it to be used in calculations. Let's start by looking at how a single token, such as apple, is processed. At first, the AI assigns a bundle of numbers to the word apple, something like a coordinate in a high-dimensional space as shown on screen. At this stage, these numbers carry no meaning at all. They are essentially random. But this is where what we usually call learning begins. As the AI is exposed to massive amounts of text, it begins to detect statistical patterns. It finds that words like eat, tasty, and fruit frequently appear near the word apple. In response, the AI gradually adjusts the numerical representation of apple, placing it closer to those related words within this abstract number space. On the other hand, words associated with cars such as engine, wheels, or driving rarely appear near apple. As a result, their numerical representations are pushed farther away from apple in this space. In this framework, meaning is not understood in a human sense. Instead, it emerges through distances and relationships between numbers. As training continues, the numerical coordinates for words like apple and fruit settle into very similar locations. If you look at the visualization on screen, the similarity is clear. Because these words frequently appear together in similar contexts, the model adjusts them to sit close to each other within numerical space. In contrast, apple and car rarely appear together. As a result, they are placed in completely different regions of this numerical space. By representing each word as numbers in this way, AI becomes able to calculate how closely related different words are, purely in probabilistic terms. This process of assigning numerical representations to each token and arranging their relationships mathematically is known as embedding. In a sense, this can be thought of as translating something humans do naturally into mathematics. When we hear the word apple, we instantly associate it with fruit or something tasty. AI produces a similar effect, but not through understanding. Instead, it relies on numerical distances and calculations. And based on this network of numerical relationships between tokens, the AI continuously calculates which word is most likely to come next. Repeated prediction of the next word is the core mechanism that drives conversational AI. Now let's move on to the next step. Once a sentence has been converted into numbers and the probabilistic relationships between words have been calculated, one major question remains: how does AI use these numbers to produce a sentence that actually fits the context? For a sentence to sound natural, its context must flow logically. For example, if someone asks, "What kind of fruit is an apple?" and the AI responds, "An apple is an interesting car," the context is clearly wrong. Likewise, the output cannot be grammatically broken, such as "Is apple fruit tasty?" To address this challenge, modern conversational AI relies on a very important computational approach. In fact, this idea sits at the very core of the systems we use today. Earlier, we explained that AI breaks sentences into very small pieces during processing. Interestingly, when it comes time to generate a sentence, it doesn't treat words in isolation. Instead, it looks at the sentence as a whole. In other words, when the AI selects a word, it calculates which other words in the sentence matter most for maintaining context. For example, in the question, "What kind of fruit is an apple?" the AI evaluates how strongly every other word relates to apple, assigning each of those relationships a numerical weight. Now let's take a look at what those calculations actually look like. In this visualization, the AI assigns attention weights across the entire sentence. When the reference token is apple, the strongest weights go to fruit and apple itself, while function words like of, is, and an, as well as the question mark, receive much smaller weights. The same calculation is performed for every other token. For example, when the reference token is fruit, the largest weight goes to apple, followed by fruit itself, and only small weights are assigned to the remaining words. In other words, the model identifies which tokens matter most for each word and uses that pattern to keep the sentence coherent. Once all of these calculations are complete, the AI arrives at a clear picture of the context. It recognizes that the sentence is a question, that the core concepts are apple and fruit, and that grammatical particles or endings are not essential to the meaning. This entire process is known as self-attention. Based on this computed context, the next step unfolds much like what you see in the video. The AI generates a set of candidate words that are probabilistically close to the words in the question. From these candidates, it selects the words that best fit the context one by one through probability calculations. This is how different responses like "an apple is a fruit" or "an apple is a sweet fruit" can be produced. Even for a question that seems extremely simple, there's an enormous amount of computation happening behind the scenes. So where do we stand now? At this point, we have walked through the entire process by which conversational AI generates its responses. Of course, real-world systems are far more complex and rely on much larger models and far more extensive calculations, but the core idea behind how answers are produced remains very close to the framework you have just seen. The key point to understand is this: AI does not think. What it does instead is repeatedly calculate and select the single word that is statistically most likely to come next, nothing more than that. However, by training on the vast amount of text produced by humanity, AI has absorbed patterns of reasoning, explanation, and argument that tend to sound logical in human language. That's why its responses often feel coherent and well-structured. But AI does not understand the meaning of the sentences it generates. As a result, it can present incorrect information with complete confidence or deliver inaccurate numbers while sounding entirely certain. For this reason, many researchers point to clear limitations in today's conversational AI. Modern AI systems are trained on vast collections of existing human output, including text, images, and videos that people have already created. AI does not engage in creative thinking on its own. Instead, it learns patterns from the products of human creativity and reproduces those patterns in new combinations. Because of this, for AI to develop richer forms of expression or generate genuinely new combinations beyond what we see today, the underlying source, human creative output itself, must continue to grow and evolve. However, there is another concern that has been drawing increasing attention. As the volume of AI-generated content grows explosively, there is a real possibility that future training data will contain an ever larger share of content produced by AI itself. In that case, AI would no longer be learning primarily from original data shaped by human thought. Instead, it could end up learning from outputs that were themselves produced through probabilistic calculations. Some researchers warn that if this cycle repeats over time, AI outputs may gradually converge toward a more average or generic form, with reduced diversity in expression and fewer unusual or unexpected ideas. That said, this is not a fixed or inevitable future. It is better understood as an ongoing discussion about the potential limitations and structural risks inherent in today's AI systems, rather than a definitive prediction of what will happen. AI is a system that repeatedly chooses the option that is statistically the most likely. Humans, by contrast, sometimes make choices with extremely low probability, for no obvious reason at all. And interestingly, it's often in those moments that creativity emerges. I'm not sure whether this kind of human unpredictability can ever be fully captured by mathematics. Perhaps that difference is precisely why AI may never be able to completely replace humans. So personally, I cannot help but wonder whether AI today is similar to fire in humanity's past, a powerful tool that once sparked a dramatic leap forward in civilization. Maybe artificial intelligence is simply another tool now placed in front of us. What do you think? I hope today's video helped you understand AI just a little better. With that, this episode comes to a close. I'll see you next time with another fascinating story. Until then, see you in the next video.